Thank you very much for the introduction. This is a joint work with Lucy Spess at the University of Sheffield, and this work was funded by the European project called Simpatico. So when you think about text simplification, the idea is to transform an original text into a simplified version. So in the example that I have here, you can see that there are several things happening in order to transform the top sentence into the simplified version on the bottom. So for instance, the phrase "the researchers say" was dropped, the word "disappear" was changed by "be gone," the sentence was actually divided into two, where the while conjunction was. So a lot of operations happen in order to generate a simplified version. We do simplification for a specific target audience. So for instance, we can think about simplifying for non-native speakers of a language or people with low literacy levels. We could also think of simplification for improve other natural language processing tasks, such as machine translation, for instance. When you think about data-driven text simplification, we need parallel data. So it's similar to machine translation tasks, for instance. The most used data set in this scenario is the Wikipedia Simple Wikipedia data set. It's aligned articles from the original Wikipedia to simplified versions. However, this data set is rather small. It's not produced by professionals, so the simplifications are not generated by professionals. And there is no defined target audience on this data set. So they have some guidelines for simplification, but they are general. On the other hand, the Newsela dataset released by the Newsela company, the original articles have simplified versions that actually target different grade levels in the United States. So, and also this dataset is actually produced by professionals. So original article in this dataset has up to 4 simplified versions, and each simplified version will be on a lower grade level. In order to use this data for sentence sequence approach, we need a sentence level alignment. So we do it automatically, and these alignments actually can be classified in 4 classes. So you can say that original sentence was actually kept in the simplification. Can also have managed one, where several sentences was merged into one sentence in the simplified version. One-to-many, when one sentence was split into several sentences, and also elaboration, where it's still one-to-one alignment, but the sentences are different. We also produced alignments between the original documents and all these possible simplified versions, and also between the simplified versions. So this resulted in around 550,000 sentence pairs, which almost more than doubled the size of the Wikipedia data set. Sequence-to-sequence approach for natural language processing is being the new state-of-the-art for several tasks. It's not different for text simplification, so the NETS system is the new state-of-the-art for Wikipedia and simple Wikipedia data set. However, all this work, they didn't take into account the specifics of different audiences. So because the Wikipedia data set didn't have this information as well, they didn't account for that. But now that we have a data set with such information, we could try to explore it. So thinking about the approach of a Google multilingual neural machine translation approach from last years, what they did was they used an artificial token to guide the encoder in order to do the machine translation. So if I wanted to translate from English into Spanish, what they did was add an artificial token on the beginning of the source sentence with a specific of the target language. So here, to Spanish, for instance. So our approach is to add artificial token on the beginning of our source sentence to guide the encoder on the simplification of the target sentence. So basically, if I want to simplify the top sentence to a grade level 2, I just add this information to the top sentence. Advantages of this approach is that you can generate more adequate simplifications for audiences with different educational levels. It is a real-world scenario, can be applied in real-world scenario because an end user can provide his or her grade level. And it's also robust for repetitions on the source sentence. So one problem with the alignments that we generated is that the same source sentence can be aligned to different simplifications. In this case, we can actually guide the encoder to a specific simplification that we want to provide. So the same source sentence can be simplified to different target levels. We could also think about the simplification operations that I talked earlier. So the sentence level alignments give this classification, and we could use this information also to guide the encoder. So in this case, I'm telling the encoder that the source sentence should be split or should be elaborated and so on. The problem is that, unlike different from grade levels, this information is not available at test time. So what we did is we experimented with a classifier for this task. We built a simple classifier with naive Bayes and 9 simple features. And the idea here was just to, as a proof of concept, to see which type of results would get. In terms of architecture, we didn't change the neural-machine translation architecture, so we used a neural-machine translation approach. The only thing is that we added this artificial token to the beginning of the source sentence, and then the network should account for that. We experiment also with an NTS system without artificial tokens. We created a baseline with no artificial tokens as well. And we experiment with a grade level system, operation system with operation, information, and a system with both. So combination of grade level and operation. So our result shows in terms of BLEU that represents grammaticality, and SARI that represents simplicity, that you have mainly in terms of SARI, you have a huge improvement when you use our grade level system. When you use the predicted operations, it doesn't improve much as the grade level, but it's still better than the baselines. But if you use the gold level, the gold standard operations, then we have a better improvement, meaning that if we improve our classifier, the results will probably be better. So just an example to show the usefulness of this approach. So if I have an original sentence and then I just use either our baseline system or input the token 10, 9, 8, or 7, the sentence would be repeated. If I input the token 6 or 5, so grade level 6 or 5, the sentence would actually be split. If I put 4, there would be some changes in lexical simplification as well. 3 more changes happened, and with 2 more, even more changes happened. So there are different changes happening for each grade level in this case. This approach also enables zero-shot text simplification. So if I want to simplify from grade level 12 to grade level 4, but I don't have this information on the training set, this is also possible as long as I have the information of other levels into the level 4. So we experimented with this. We removed all the 12 to 4 sentences on from the training set and trained the system with this and tested with the sentences. As you can see, BLEU and SARI are comparable to the grade level system that had the full information. They are both better than the baseline. However, if you test with grade levels that are actually quite close, so 6 to 5, the results are not that impressive, which is expected, probably from level 6 to level 5, grade level 6 to level 5. The differences are not that big in terms of simplification. So just to conclude, we need to start mainly on data-driven approach, data-driven work. We need to think about for who and which is the purpose of the simplification. So text simplification without a target audience may not produce ideal results for the end users. Also, the simple artificial token approach can improve the quality of text simplification. It also enables a more personalized simplification in terms of grade levels, and it also enables the zero-shot text simplification. And finally, the simplification operation information can help, but of course you need to try better classifiers for the task, and as a future work, you can think about a multitask learning where you can learn both tasks together, so predicting the operations and the text simplification. So thank you very much for coming, and if you have any questions.
Questions?
Hi, Sandra Utenboged from RMIT. It's great seeing work on this happening. For specific target audiences, one thing that I found in my own research was that different language backgrounds impact what is considered easy and difficult for somebody to read. And most of the data available tends to be based on the assumption of if it's easy for a child, it's easy for a non-native speaker. What do you envisage changing in terms of technology techniques for it to work better? Is it just changing the data set, or will there need to be change in techniques as well?
I don't know. In my opinion, one way to go, since it's quite difficult to change the data set and building a data set from scratch, is if you can create a smaller data set and then tune the system on this direction, it may be a way. Of course, that there are some situations where, even though it's not ideal, it should still work. So let's say you have this data set, Newsella, is specifically for grade levels from learners of English that are native speakers of English. May work for some cases of non-native speakers, probably not all of them. So we would probably need to work a lot on evaluation to see to which level you need actually to tune your system as well. But I think one thing that we are actually planning to do, because the Simpatico project is actually aimed at non-native speakers, the idea is to create a smaller data set, controlled and a high-quality data set, where we can then use later on to tune our system for that. Thank you.
Thanks for the talk. And I think your method is simply adding the artificial token in the beginning. Yeah. And you use the baseline model like attention-based sequence. So I wonder if you have any analysis about how the artificial token is affecting your simplification. Why is it different from the basic text simplification? Because I think you use BLEU score. BLEU score cannot really reflect it is for a specific target audience.
Yeah. Yeah, it's a really good question. We actually didn't do a deep analysis on the data to see. One problem that we have with this type of things is that whenever we have different grade levels, it's quite difficult also to send for human evaluation as well, because a proper human evaluation would need to be for a specific grade level as well. So we didn't do this analysis, but what is happening here, I had a look on some sentences, and I got these examples from these sentences, is that the system is actually being able to learn something different for these grade levels. Of course, we probably need to extend this analysis, and it is something that we want to do. Yeah. But we started with the same assumption as the conclusions from the paper of Google Neural Multilingual System, that the token basically guides the encoder on how to encode the sentence to translate to a given language. So here we have the same assumption But yeah, with definitely a deeper look into the data as well.
Yes, thank you very much.
Please thank our speaker again.
Yeah, sorry. Just one quick thing. So you show that obviously if you go from 6 to 5, you don't have much of an effect. If you go from 12 to 4, of course, you get a huge effect. Now, obviously, you would imagine that the development is non-linear, right? So if you go from 1 to 2 and from 2 to 3, maybe there is more difference than from 11 to 12. So I was curious if your data actually confirmed this basic intuition.
We didn't. I don't have the results for all the pairs, so I have done only for a couple of pairs that are on the paper. But yeah, this is actually interesting to see.
Yeah, right, because you would think that at the beginning you learn more, and then in the end
you learn less. Yeah. Another thing about this data set is that you don't have much information about it, so we actually assume that the data was produced from, let's say, 12 to 4, and then the 4 to 2, but maybe they are not related, so there is also probably a little bit of noise there that we don't know where it's coming from.
So thank you again. Yes.
Thank you.